All right, guys, this is the start of section 2.4, which is really the start of our proofs. Like, we're going to get hardcore into proofs over these next three sections. I hate to be the bearer of bad news, but for the vast majority of you, this will be like the big picture thing you guys hate the most this year. And it will be trying at first. You're going to get frustrated at first, but just know that's okay and it's normal. It's normal to struggle at first, but we'll do lots and lots and lots of practice until you'll eventually get it. I promise you will. If you buy in, you'll eventually get it. Just don't get frustrated to the point where you shut down. All right, so before we get into some hard geometric proofs, this section we're going to go over some algebraic proofs. So before we do that, we need to discuss some properties that we learned in algebra and just review them. So the first one is the addition property of equality. Okay, so the addition property of equality is basically when you add the same thing to both sides of the equation. Okay, so if I were to have, I don't know, 5 plus 2 equals 7. Everyone agrees that's a true statement. Well, I could come over here and I could add 8 to both sides, and both sides would still equal. It would still be a true statement. So we can do that because the addition property of equality tells us. So once again, we can add the same thing to both sides of the equation, and that equation remains the same. It remains equal. All right, subtraction property of equality, kind of same concept, but now we could subtract the same thing from both sides of the equation. Multiplication property of equality, we can multiply both sides of the equation by the same thing. And then, of course, the division property of equality, we can divide both sides, or should be divided by side, by the same number. Okay, substitution property of equality, you use this a lot and you don't even realize you do it probably, but all it tells us is that if A and B are equal, we can replace A with B in any expression. So let's think back to Algebra 1 last year. So say we had 5x plus 9 equals, I don't know, just 5x plus 9. Okay, and so you do this math and you find out that x equals 3. Okay, so what you've learned is you can substitute this 3 in for x. And the reason you could do that is because we're told that x and 3 are equal. Okay, so when we do that, it's 5 times 3 plus 9. All we did is substitute it, right? Because x and 3 are the same. So 15 plus 9, which is what? 24. Okay, that would be an example of the substitution property of equality. All right, so the distributive property now. And we've done this quite a bit, and I just put a plus I just put plus or minus in both of this. So if we have 5 times x plus 3, I don't know, or x minus 3, it works the same way. We all know that when we distribute, this 5 has to go to both the x plus 3. So it's 5x plus 15. That's the distributive property. The associative property of addition, basically when it comes to 3 different terms, we can add in any order. So we can add the first 2 first and then add it to the third, or we can add the first to the second and third first, and it doesn't make a difference. It comes out to be the same. The associative property of multiplication, once again, we can multiply in any order. The commutative property of addition is a little bit different. So now we're just talking about 2 terms, and all it is A plus B equals B plus A. So we can flip the A and the B and it doesn't remain the same. So 5 plus 2 is equal to 2 plus 5. That would be the commutative property of addition. Okay, notice there is no commutative property of subtraction and there is no commutative property of multiplication. So let's think about this for a minute. If there was a commutative property of subtraction, we'd have 5 minus 2 equals 2 minus 5. Well, this is positive 3, this is negative 3, so they are not equal. Okay, that's why there's no commutative property of subtraction. Commutative property of multiplication, we can multiply 2 numbers in any order. A times C equals C times A. The reflexive property of equality, guys, this seems ridiculous at this point, and I get that. But I promise you, it will be very, very relevant when we get to our congruent triangles chapter. We will use this a lot. It'll become our best friend. So the reflexive property equality just tells us something is equal to itself. Like literally something is equal to itself. So maybe it's 7 equals 7. Y equals Y. Angle A equals angle A. I mean, the list goes on and on and on. But the left side of the equation, the right side of the equation are the exact same. Think of like you're looking in a mirror to see a reflection. You see you. The symmetric property of equality, you can flip what's on each side of the equal sign, and it doesn't matter. So A equals B, then B equals A. So if we're doing a problem and we get like -5 equals x, okay, we can flip that around to say x equals -5, and it would mean the same thing. That would be an example of the symmetric property of equality. All right, let's do an example here. Okay, so we have this algebra problem here on the left, and luckily for us, it's already worked out. Okay, so we're given this equation here. Okay, now we're just going to go through the process step by step by step. You have to write down and show every single step when you're doing a proof, but we're going to go through the process to see what we did here. Okay, so notice from this line to this line, the only thing that changed is this left side. The right side remained the same. And the way that changed is we distributed. So distributive, and I'm going to abbreviate, property of equality. Okay, we just distributed. Now, if we look again, this right side still hasn't changed, but this left side has. So 2x plus 6 minus 5 is equal to 2x plus 1. So all they did is they did a little bit of math to get this. So I'm just going to say we just simplified the equation. Plus 6 minus 5 is just a plus 1. All right, so from here to here, 2x plus 1 equals 5x plus 4 changes to 2x minus 2x plus 1 equals 5x minus 2x plus 4. So notice we are introducing this minus 2x on both sides of the equation. Okay, so for subtracting the same thing from both sides of the equation, that is the subtraction property of equality. Okay, now once again, let's do some math. So 2x minus 2x, they go away. 5x minus 2x is 3x. So all we did here is we simplified. All right, now let's look down here. 1 goes to a 1 minus 4. 3x plus 4 goes to a 3x plus 4 minus 4. So once again, we are subtracting the same thing from both sides of the equation, which is the subtraction property of equality. Okay, now we just did a little bit of math, so we're going to simplify. Okay, now here, notice we're dividing both sides by 3. So if we divide the same thing on both sides of the equation, that's the division property of equality. And once again, guys, I am abbreviating this. Feel free to abbreviate as well. And then when we do some math, we simplify, we get -1 equals x. Now notice here, we do change it. We go -1 equals x to x equals -1. So what property did we just talk about where you can flip what's on each side of the equation? That's the symmetric property of equality. So congratulations, you just completed your first proof. All right, let's do another example together. This time we have to work out the algebra. Okay, so what we're going to do is we are going to draw a T-chart. So it's just a chart that looks like a T. And we have our reasoning over here, or our statements over here, I guess, statements. And you don't have to write this. And then we have our justification over here. Okay, so we're always going to start with what we're given. 3x plus 2 equals 23 minus 4x. And this was just given. All right, so let's think of this as a normal algebra problem. Typically, we don't like negatives, so I'm going to add a 4x to both sides of the equation. Now, I know the one before did it all horizontal. I'm going to do it vertical. That's okay. Okay, so when we add the same thing to both sides of the equation, that's the addition property of equality. And when we do that, 3x plus 4x is 7x. We're left with a plus 2 equals 23. Here we just simplified. Okay, now let's move this 2 over. So subtract 2. If we subtract it from the left, we have to subtract it from the right. We subtracted the same thing from both sides of the equation. So that would be the subtraction property of equality. So now we're left with 7x equals 21. That is a simplified. Get x by itself, we want to divide both sides by 7. So when we divide by the same number on both sides of the equation, we get the division property of equality. Those go away, so we're left with x equals 3. And that's just to simplify. That's all there is to it. All right, guys, now that we've done a couple of examples, I want you to go ahead and try this one. Treat this the same as the other two. So try to work it out on your own, and then you can check it when you're done. All right, so this is my proof filled out. Yours should look something like this. Now, I'm assuming there's going to be a handful of you that distributed this first, and that's okay. You just do distributive property of equality and go. But the end result should be the same, w equals -2. And you should have simplify about every other step on this.